Hey everybody, this is Caleb one more time, and in this video we're going to talk about control flow, specifically different kinds of loops in code. And as a loop indicates, a loop basically repeats code for every item in a collection or while a specific condition is met. We're going to actually get started with the playground here, and we're going to dive right into using loops. They're very cool, very helpful, but there are a few things you need to know. So go ahead and create a blank playground, and let's make this let's get loopy. There we go, beautiful. And we don't need that to be so huge. Cool. Okay, so I am going to make this taller because we're going to be printing out a lot of stuff in the console. So get rid of this boilerplate string here, and we're going to begin with something called the for loop, okay? Now, a for loop allows you to iterate over a sequence like an array or a dictionary, or even a range of numbers, and it allows you to perform the same operation on every item in that collection. So let's go ahead and let's create a quick collection here called names, and it's going to be an array, and I'm going to pass in some names here and put a comma there. And just to make this faster, I'm going to copy and paste this a few times. And let's go ahead and just put in a name here, Peter, Paul, Mary, and I don't know, Frank. Why not? So what we are going to do with our friends Peter, Paul, Mary, and Frank is we are going to create a for loop. And in order to do this, we're going to go ahead and type for, and then we're going to basically, what I like to do is if the collection has a plural name like names, I like to take the singular version. And so I'm going to say for every name in the names collection, and inside we can tell what we want to do with the names in the collection. Now, there's a warning that pops up here, and it says, immutable value name was never used. Consider replacing with underscore or removing it. But we want to use it. We don't want to remove it. Basically, what happens when we declare a for loop like this is this property that we name here, whatever we name it, we could name it name, we could name it, N or M or whatever. Whatever we name it, that's like a temporary variable. And what it's going to do is it's going to loop through this collection. So right now, at the beginning, name would be set to Peter. Then, if I wanted to use that variable in here somewhere, I could. And then once it's done, it's going to switch, and now name will be equal to Paul, then Mary, then Frank. And to see how this works, check this out. We can go ahead and print a little string here, and we can just say hello, and we can pass in the name parameter. Check this out. Let's put an exclamation mark at the very end. And if this for loop works the way that it's supposed to, it's going to say hello Peter, hello Paul, hello Mary, and hello Frank. Let's print it out and let's see what we get. Look at that. We get exactly what I thought we would. Basically, this for loop is going to loop through this collection, set the value of the first item to name, and then run the code inside the loop. Afterwards, it's going to go ahead and switch to the next item, and the next item, and the next item, until all of the items have been exhausted. You can do this with dictionaries as well in pretty cool ways. So let's create a quick dictionary for the number of legs of animals. Let number of legs equals, and this will be a dictionary, so we're going to use some curly brackets. We're going to do a string, and the value for the actual key value pair will be an integer. So let's think we want to do maybe a spider first, and we'll put 8 legs for a spider. A dog we know has 4 legs, and a human, or a humna, has 2 legs. So now that we have this dictionary, we can go ahead and write a for loop, and we can use both the key and the value. Check this out. For, and we're going to use some parentheses here, we can create a parameter for the key value, and we can create a parameter for the value. So we can go ahead and type animal type, like so. So animal type is the keys, and the values is the leg count, right? That's the name of the property. So for animal type and leg count in the number of legs dictionary. And now what it's going to do is it's going to loop through all of these and give us access to both values for each entry in the dictionary. So what I can do is I can print out a little compound sentence here. I can say, let's pull out the animal name first. So animal type, and we're going to make them plural. You know, spiders, dogs, have. And now let's put in the number here, leg count, and legs, period. If I print this, you'll see it will loop over every collection and print out those values. How cool is that? We're writing code once, but it's performing the same operation 3 times for 3 different sets of data. That's pretty cool. Let's go ahead and continue with another way for loops can be used, and that is with numbers. So let's say that I don't have a collection like so that I can pull from. What I can do is I can just go ahead and use a range of values. So let's say I wanted to do some type of math. And so I can say for index, I'm going to use this index parameter to hold a value. For index in, and let's do a range of numbers. I want to go all the way from 1 all the way to 5. And this is actually exactly how you declare that, with 3 periods. 1.5 says I want to count 1 all the way up to 5. And what I'm going to do for that is I'm going to go ahead and print out another compound sentence here. And I'm going to use the index value. So let's do index. And let's just imagine that we're starting at the beginning. So this would be equal to 1. 1 times 5 is equal to... And now we can actually do some math and print it out. We can take the index value, which in this case is 1. We can use the asterisk sign, which is for multiplying, and we can pass in 5. Then when we run it a second time, it'll say 2 times 5 is equal to 2 times 5, which is 10. So let's print this out. And look at this. We just did 5 math problems in 1 second. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. Now, as you can see, for loops are very helpful. And there's one other thing we need to know. And that is, what if we don't want to go all the way to the end of our index? What we can do is we can use another type of symbol. Now, let's say that I wanted to count all the way up from 1 until 9. I could type for index in 1.9, and I could print out, the index. Let's try that out. Let's print out the index value and see what we get. Okay, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's very cool, but let's pretend that we are doing this for our names array. And we know that there are 4 items in our names array. Let's say that I counted all the way up 1 to 4 and I ran it. We get 1, 2, 3, 4, and that is great. But remember, there are 4 items in this array. If I wanted to basically print out all of the names, check this out. If I typed names and then passed in the number here as the index, watch what happens when I try to print this. Fatal error, index is out of range. I thought there were 4 items though. Remember, arrays use 0 indexing. So what I can do is I can say if I want to go from 1 all the way up until below 4, I can use the less than sign instead of that last period. And watch this. If I print it, we are now good to go. That prints all the way from 1 up until 3, 1, 2, and 3. However, since it is 0 indexing, we can go from 0 all the way up to 3. And we can print out all 4. So if you are in an instance where you need to use the index path of some type of array or a dictionary, I would recommend using the less than symbol in this for loop. Okay, so that is for loops. Basically, you can pass in collections, you can set a temporary parameter, and then repeat the same code over those parameters as it goes through the collection. You can also use dictionaries or even ranges of numbers, going from the lowest value up to the top value, or you can set it to go from a value all the way up to the value just below the one you declare. Next, we need to talk about while loops. And while loops are really cool because they operate while a condition is met. And these are the dangerous ones. These can cause what is called an infinite loop, and it can actually crash your computer if you are not careful or developing on an older platform. So what a while loop basically consists of is this. We're going to basically say while a condition is met, we are going to execute execute code. Okay? So while a condition is met, we will execute code. So let's go ahead and set up some imaginary properties for an imaginary board game. I'm going to create a score parameter and set it to 0 from the beginning. I'm going to go ahead and set a variable to hold the value for a dice roll. Okay? And we'll set that at 0 as well, because it doesn't really matter what it is right from the beginning. And I'll actually make my code a little bigger here so you can see. There we go. And so what we're going to do is we are going to say while score is less than 20, we're going to do some math to determine what the dice roll is. We're going to roll a random number, and if it is 4 or less, we're going to award 1 point. Otherwise, if they roll a 5 or a 6, we're going to subtract a point. Okay? So this is kind of a way that you could generate a text-based game in code. So while the score is less than 20, let's roll the dice. We can call dice roll, and we can set it to be equal to a random number that is 6 or fewer. And there's a special function called arc4randomUniform with upper bound. Don't worry about this, but basically this function generates a random number, and we can pass in a 6 here to say that is the highest number we want it to be. This is not the right format, so we need to actually convert it to an integer. Don't worry about this too much, but we're going to go ahead and convert it to an integer. And if I run this, you'll see it's going to basically endlessly run my code. Do you see how the number just keeps going up? That is how many times it ran my code, because my score was never changed. It's still less than 20. If I run this, it's going to run it hundreds of thousands of times until Xcode crashes. So I'm going to stop it so it doesn't crash my Xcode app. And we're going to do something to actually change the score so that it will eventually end. So we have rolled our dice, we have set it to be a random number, and as you can see, if you look at the data, it's all over the place. I don't think we can actually get a great visualizer on that, but basically it's rolling 79,000 random numbers that are between 0 and 6. So what we can do here is we can actually print what our dice roll is, like so. And you know what, let's put a little key at the front here. Let's just say dice roll. And then let's separate those with a comma, so we're printing out both of these items, and that will actually show us down below what we rolled in our game. I'm also going to basically print out a line break. Don't worry about this, you can just type it, but it's basically going to just return a blank line so that we can see what the score is beneath it. So we're going to roll the dice there, and then we're going to check using what is called a conditional, and we've talked about these before. We're going to say if the dice roll is less than or equal to 4, we're going to go ahead and essentially make the score go up. So we're going to go ahead and say score equals score plus 1. So 0 plus 1, that's now the score. We added 1 point. Then we're going to go ahead and print the score so we can see what it is. So we'll say score, and then we're going to go ahead and print the actual score variable. So let's go ahead and let's try this out. Let's run the game. And as you can see, it did that 23 times. It only took 23 tries to win. So we can go through and look here. So we started, we dice rolled a 1. So our score was 1. That's less than 4. And we dice rolled a 3. Our score is 2. We rolled a 4. Our score is 3. We rolled a 5. No score. That's interesting. We rolled a 1, our score went up to 4. We rolled a 0, our score went to 5. We rolled a 2, our score went to 6, and so on and so forth, all the way up to 20. However, we're not accounting for the fact that we could roll a 5 or a 6. We're not doing anything with the score. What we can do is, instead of just saying else, we can say else if, and we can add a second condition. Else if dice roll is greater than or equal to 5, we can take the score and subtract 1. So score would then equal score minus 1, like so. We can then print the score, so I'll just copy this and paste it below. And now if I run it, check this out. I can go ahead and take a look through my game, and it's not going to be as easy. As you will see if I look here, it took 24 times to do this, and I rolled a 5 or a 6 only 2 times. But watch, if we go through and find when we did that, our score was 6, we rolled a 0, our score was 7, we rolled a 4, our score was 8, we rolled a 5, back down to 7, then our score was 9, we rolled a 5, back down to 8, So as you can see, there is a random draw here that is happening. We know that the highest number that will be rolled is a 5 because this is the upper bounds of the random numbers. And we know that if the dice roll is greater than or equal to 5, meaning 5 or 6, we're going to subtract a point. If it's less than or equal to 4, we are going to add a point. And right now, our game is pretty good, except if we rolled a 5 or a 6 from the get-go, that would allow our score to be a -1. And if that were to continue randomly, which is super unlikely, but it could happen, it would cause an infinite loop. So we need to make sure that we're being smart about the way that we do this. So when our score comes in, it is 0. And we need to make sure that our score is never negative. That doesn't really make sense. It should just stay at 0. So what we're going to do is inside this else if clause, we're going to go in and type if score is greater than or equal to 0, then we will set the score to be equal to -1. Then we're going to go ahead and print the score. So either way, our score will be 0 or it will be 1 less than it used to be. So let's run this again. Let's make sure that we're good to go. Okay, so it looks like our score here is, in fact, -1. So let's see why that's not working. Oh, okay, I see. So you know what? We did greater than or equal to. We should do if it is greater than 0. Because if it's equal to 0, we shouldn't subtract the score. We should only subtract it if it's greater than 0. So let's build that one more time. Let's go check it out, and looks like it works. Look at that. Our first roll was a 5, and our score is 0. Then 3, then 5, then back down to 0. So it looks like it's working. We are preventing our score from ever going below 0, which is very cool stuff. But really quickly, I want to show you an even easier way to do this line and this line. What we can do is we can actually just say score plus equals 1. And what that's going to do is it's basically going to just take the value of score, it's going to add it to 1, and then set the value of score to be equal to that. So we can do the same thing here, score minus equals 1. And if we run the code, you'll see we get the same exact thing as before. We're really cool stuff. Start with 5, stay at 0. This is awesome. It doesn't allow us to go down below 0. And we have a completely random dice rolling game that we just built using a while loop. So cool. This is, in essence, how loops work in Swift, both for loops and while loops. And this is actually the conclusion of our basic Swift section. We're going to head over to the next section and continue learning, but pat yourself on the back, go get yourself a LaCroix or some kind of fancy drink, and celebrate. You just learned a lot of stuff. Make sure that you go back over these videos if you don't understand, and make sure that you practice this, write code every single day. Those are the best ways to solidify these concepts in your brain. Congratulations, and let's head over to the next section.